Why don't we get started? So, administratively, of course, Project 1 is due on the 21st of this year at the usual time, 11:59 and 59 seconds. On Monday, the 20th, we have the MLK holiday. And let's see, what else is. No, they're not in this class. All right, never mind. All right. Any questions about the homework, about the project? No? Pretty straightforward. If you haven't looked at it, make sure you look at it today. Okay. All right. So last time when we left off, we talked about this idea of inferential statistics, and we talked about inference in general. And we said that when you sample, it allows you to use fewer resources, but in order to, when you do use fewer resources when sampling, it introduces some issues, and that has to do with something called experimental design, how you go out to get these samples, get these pieces of data from which you're making or drawing your conclusions. And so the example we gave when we left off was the Gallup organization. They do polling, and so oftentimes you'll hear the term, typically on the news, a Gallup poll said. And so the Gallup organization determined that you only need 1,000 households in terms of your sampling if you're trying to determine some outcome. You only need 1,000 households in order to produce the same result that's representative of every household. And that's not really entirely true. And one of the things you should ask yourself whenever you see any sort of survey or any sort of poll like US News and World Report, college ranking, Gallup polls, and so forth, you should ask yourself, well, what was the design of the experiment? Who did they go out and poll? And so, for example, if polling is done solely by, say, cell phone, right? They call people up on their cell phones and ask them questions. Well, there's a little bit of a bias there, meaning that it's not each person out there is not equally likely to be sampled because the demographic for cell phone only usage is for more fairly young people, right? Age 18 to 30. And if you have somebody which is primarily older, elderly, or retirees, they typically have landline only. All right, and that's not the general case, but there are many cases, or a significant number of cases, you're going to misrepresent in your poll if you only poll people using cell phone. You're going to miss those who are landline only, right? So your results will not be applicable to that portion of your demographic. Okay, all right. Any questions about this? Okay. Hopefully I have the right subject. I keep confusing the networking class with the analytics. Okay, this is analytics. I'm used to the analytical class being in the afternoon, not in the morning. Blame Rashamni for that. So nonetheless, continuing on, let's take a look at another type of statistics, another type of statistics that we use, can use, something called risk assessment. Now you've all seen the commercials for the insurance company where it talks about mayhem, and we lost the speaker. Okay. All right. Well, let me just move on. And so, um, in everyday life, bad things can happen, right? Lightning can strike, maybe a hurricane or some, gusty day, wind-wise comes along, blows a tree down, and it hits your house or hits your vehicle. And so you can trip and fall, you can slip on the ice, all sorts of bad things can happen. Now, of course, when bad things happen, typically there is a monetary cost associated with repairing that damage. You have to visit the doctor, and depending on insurance, it might cost you less, might cost you more. Maybe slip and fall, you're out of work, so you're deprived of income for a few days to, or maybe even a few weeks. So bad things can happen, and these bad things happening, certainly you can associate probabilities with these bad things happening, right? So you can model it as being based on chance. And because it's based on chance, there are some bad things happening that are more rare than other things, bad things happening. And so whenever you have a monetary outlay that you incur as a result of bad things happening, oftentimes that's called risk, right? Now, of course, in the finance community, risk is the term they use for variance, right? And if you think about, what happens when you buy and sell stock and other financial products, well, the more variable that price is, right, you might hit it when it's high, and then all of a sudden it swings low in price, and you could lose money if you exercise that option or if you sell that security. So this is not what I mean by risk. What I mean by risk here is financial risk, meaning that you have to pay money. You're going to lose value because you have to pay money as a result in repairing the damage associated with this bad thing happening. So therefore, if something bad happening is more highly likely, well, there's more of a chance that you're going to have to outlay more money if that bad thing across a population is more frequently occurring, right? So in that case, people take statistics to describe the likelihood of these bad things happening, and then they associate a monetary value with this. And so insurance industry is based on this. They do risk assessment. They look at population statistics. So, for example, car insurance, right? Young men between the age of 16 and 25 are the highest, most likely individuals to get into car accidents. And so when you get your car insurance, certainly if you're a younger driver or have less experience, I should say more correctly, less experience with driving, well, if you have less experience with driving, you're more likely to get into an automobile accident. And so as a result, they say, okay, what's the likelihood of this particular profile of person getting into an accident? Then what is the average cost of a typical repair as a result of various types of accidents? And then you pay a fraction of that cost regularly as your premium to guard against your risk. Because at the end of the day, while the insurance company pays out to protect your financial risk, meaning that you pay these premiums, which are typically smaller over time at regular increments, you're not going to incur that off chance of a really large payout that's going to perhaps damage you financially, right? So that's how the whole insurance industry, excuse me, works. And you resort to protecting against these bad things through other means, and that's what the insurers do. Now, of course, there's homeowners insurance, there's car insurance, there's life insurance, and absolutely you cannot place value, put a price on a life. But the real purpose of life insurance is the replacement of salary, if you will, or earning potential of the individual should he or she unfortunately lose his or her life. So you can imagine, as you get older, maybe you have a family, you have a house, or you take care of other relatives. Well, that income needs to be replaced, and that's what life insurance is typically used for. And so you resort to protecting against these bad things or the result of these bad things happening, the risk, the financial risk, through other means, and that's what insurance is purposed with. And so what typically happens, there are tools from statistics you can use to make the assessment of this risk. And then based on this, you can do something about it to protect against these bad things, such as paying money in order to get this rectified, right? So the typical person, wage earner, right, can afford to pay regular increments. Maybe it's monthly, maybe it's quarterly, maybe it's annually, a few hundred to $1,000 or $2 for insurance of various sorts. But the average person can't afford maybe a surprise bill of 5,000 or 10,000 or 20,000, and that's how this all works. So the insurance industry, as I said before, is based on this, but it's not just homeowners, car, or life. You could get personal liability insurance, right? And that exists. If you have some specialized skill, maybe you're an artist and you use your hand, like you're a famous guitar or a skilled guitar player, you can absolutely find organizations out there that will insure your hands, right? And this exactly happens. Insure your voice, your vocal cords, if something should happen. Or just insure you so that if someone decides they're going to sue you, they pay out that claim and they represent you in legal proceedings and so forth. So there are all sorts of insurances. There's also, for stock portfolio, there's a type of insurance, if you will, and it's called an option, right? And an option you can think of as an insurance policy for whether or not you believe the share price for some security is going to go up over time or it's going to go down over time. And so the hedging industry is based on these stock options, these insurance policies, if you will, for batches of company stock. And you might ask, why might somebody do that? Well, suppose you have a pool of stock, right? Let's say you have $100,000 worth of some stock, however many shares that might be. But given the current price, it's worth $100,000. And let's say you're setting that aside for your child to go to college, right? So a few months before he or she is set to go away to college, well, you know that the stock price could go up. Well, that's good for you, or it could go down. And so the reason why you might buy a stock option is to protect the value of those stocks that you have. And these options cost less than the actual share price. And in fact, you can go on Yahoo Finance or some other such website, and you actually look up the cost of an option. And an option has two things. There's a so-called call option, which gives you the right to buy something at a certain price. It's kind of like a rain check, if you will. And that call option is associated with a number of shares, but it also has an expiration date. It's good for 1 month, good for 2 months, and so forth. So people calculate these option prices. There's also a put, the right to sell a share of stock. And so people calculate these things, the options market, and you can actually look it up and just decide to buy these stock options. Now, of course, the original intention of these stock options was to protect the value of your stock portfolio as kind of like buying insurance. And of course, if the expiration date on these options expires, you just lose your money, right? When you so-called exercise the option, you're actually using the right to buy at a certain price or sell at a certain price. Now, of course, people sort of, they take something and then they try to advantage themselves with these mechanisms. And so you've probably heard the term hedge fund, and if you haven't, a hedge fund doesn't buy pools of stock. They just only buy and sell these options, right? And so not buying the stock, one could, if you really know what you're doing, just buy these options. And if you have a good hunch or a good idea about how a particular market segment operates and you buy these options accordingly, you could actually buy and sell the options more cheaply than the actual stock themselves and make quite a bit of money. And there are people who do that. Okay. The only advice I can give you is don't invest in something you don't understand, right? And that was advice given to me a long time ago, and it's served me well so far. Okay. Any questions about this? And so pertaining to this class, there are statistics you can use that will summarize this idea of quality or who's better as it pertains to things like these products that analyze for risk over time. Okay? All right. Any questions? Does that make sense? Okay, maybe we might have an assignment that'd be nice that uses options. Okay. All right. So the strategy, you evaluate the variability of some stochastic process, and then you can certainly associate a stochastic process with things like stock and things like accidents and certain other things. There's a lot of historical data about share prices, a lot of historical data about storm systems and damage to various homes and municipalities. And then you examine the likelihood of the bad event happening. You look at trends associated with the bad event. How do these things proceed over time, 1 year, 5 years, and so forth? And then you estimate a dollar value associated with the recovery from this bad event. So then you charge people a fraction of what that dollar value is for recovery. And if the event is highly unlikely, of course, you can make a lot of money as an insurance company. If it is more common or more likely to happen, well, certainly the insurance company charges you more, right? So that's why when you get into, if you get into a car accident, I hope you never do, that's why your insurance premium goes up. Because they say you were in an accident, you are now a quote unquote bad risk, right? You start out in what's called a risk pool, an association of you into a particular group based on all sorts of these types of assessments, a risk pool. And then if you get into an accident, they say, okay, well, you are now even more risky. So your risk goes up, your likelihood of bad events, because people are habit-based, and then they increase the premium accordingly. Okay? For life insurance, if someone is deemed as being very healthy, Well, the life insurance premium is going to be smaller in dollar value because if they deem you or assess you as being more healthy, well, the theory is that you're going to live a really long time, right? So it's going to pay out well for them. They're going to keep collecting these premiums but not have to pay out in a long time. If you are assessed as being less healthy, well, they don't think you're going to live as long, so they charge you more for insurance. And past a certain point, they'll say, sorry, we're not going to let you participate in this insurance. Okay. Any questions about this? And so you'll find for certain occupations, they're inherently dangerous just in doing your job, right? So, you're a computer scientist, you sit down at your desk, you do stuff, you walk across campus. There's risk associated with just about every aspect of life. But there are other occupations like a firefighter. Just in doing your basic job, you could lose your life. And so very often you'll see for certain occupations, they have professional groups and unions and stuff like that because they're not eligible for insurance. If you say, what do you do for a living? Every day I run into a burning building. Well, that's a pretty dangerous thing, right? You might not live very long doing that. And so for that reason, a lot of these organizations carry their own insurances because they can't get insurance from traditional insurance companies due to the inherent risk involved. If you are a parachute instructor, you will not get life insurance policies. Police officers are the same way, right? In simply just doing their regular job, often they don't get insurance. Military is the same way. They don't get insurance if you're active in theater of war. Okay. All right. Any questions about this? So certainly using statistics, one very big field that people often go into are the folks that crunch the numbers and come up with statistics that measure and quantify these ideas of risk, likelihood of a bad event. Okay. All right. Any questions? Does that make sense? Yep. All right. So let's take a look at this last type of statistics. We talked about descriptive, inferential, risk assessment. And this last one, and this isn't completely exhaustive, but it just kind of gives you a broad category of different types of statistics. And this is to identify relationships. And so this diagram describes the supply chain of chocolate, right? Unless you're allergic, most people like chocolate. There's quote unquote good chocolate, there's bad chocolate. You can talk about the cocoa content. You can have dark chocolate, you can have milk chocolate, you can have white chocolate, which isn't really chocolate, but all sorts of chocolate. Chocolate has very high value on the market, but to get from the raw material, the plant that grows the cacao plant, to actual chocolate bar, right? There are a lot of steps involved, and those steps are called the supply chain, right? How you get from the raw or most raw material to the end product. And it just goes without saying that there is some processing that happens along the way as you go from one step in the supply chain to the next step. And of course, at each step, as a result of this processing, something gets refined, something gets improved, or so forth, and there's increased value associated with it. So if you're somebody like McDonald's, right, at the end you have a hamburger, and this is only a single chain in the supply chain, but in order to get that hamburger, you have the wheat for the bread, you have the beef for the burger, the patty part, you have the mustard seeds and other stuff for the mustard, you have the tomatoes for the ketchup, you have a lot of different things that feed into this end product. So I just wanted to simplify it in this diagram, which I found online, just to show you a single chain. So you start with the grower, right? That's the cacao plant. Now, there are a lot of things affecting the growing season, right? It could be an unseasonably warm season. That affects the quality, maybe beneficially. If it's too warm, it's detrimental. Maybe there's a drought. There's not enough rainfall, right? That affects it detrimentally. If you have enough rainfall, you get a bountiful crop that season. But if you have too much rainfall, you get mildew and you get rot, right? Root rot. So there are all sorts of factors that can influence not only just the first waypoint in the supply chain going from cacao to finished chocolate. There are other factors that affect everything. Harvesting, right? So it grows and somebody has to harvest it. They have to pick it, they have to evaluate it, and they have to transport it to where the first step is going to be harvested. So of course, to harvest, Well, people are working on farming robotics. It's a new area of research in the last like handful of years, 3 years or so. But when you harvest, that's very labor intensive. So things happen that impact labor. Maybe there was an outbreak of flu or something in that area where the harvesting is happening. So a lot of people are sick, and so the harvesting is behind schedule. Things just rot because these are perishable. It has a shelf life, if you will. Or maybe there's a labor dispute, right? People are not happy about benefits or about salary and so forth, right? That's going to impact your harvest. Maybe wherever the harvest is happening, maybe there's an event of political unrest, right? That's going to affect your harvest. So all sorts of things, both human things as well as natural things, will impact your harvesting. Then there's the fermenting and drying, and I'll post a YouTube video of the chocolate making process. It's actually pretty interesting. And so if you've ever used cocoa butter lotion, I'm a big fan of cocoa butter. It's the actual fat part, if you will, from the cacao plant, and it's a byproduct of the harvesting. When you go from harvesting to fermenting, there's a seed inside of the cacao fruit. It looks like a papaya, right? And it's like yellow or brown, the cacao plant. And so there's like the meat of the plant itself, and inside are these little pods, and these pods are these kind of oblong football-shaped seeds, and they're brown or white. And those seeds are cacao seeds. But the meat of the cacao plant, when you extract the fats from it, the natural fats, like how you have olive oil, that's cocoa butter, right? So you take these seeds, these pods, and then you ferment them, right? You let them sit and they'll ferment. It's almost like not quite rotting. It's fermenting. I can't really describe. It's not the same fermenting as an alcohol fermenting because that's a byproduct of yeast digesting starch. So you ferment them. Then after that, you dry them. And after you dry them, you have these fermented dried cacao seeds. And then you go and you sell them on the market somewhere. Now, of course, when you sell them on the market, there's a lot of things that can impact the market price. That's where you get bulk things. You can have a lot of cacao seeds fermented and dried at the market, so the price goes down. Maybe there's an issue with transportation. The price goes up. All sorts of things can impact it. So then the market then packages them up because multiple farmers will sell at the market, and it gets packaged up and sent to roasting and grinding. So it's roasted just like how you'd imagine a coffee bean is roasted. If you've ever seen coffee bean, it's a small kind of roundish red. My grandfather grew coffee, a small roundish red bean, and you have to dry it and then you roast it. And when you roast it, now it gets that really kind of brown, crispy consistency that you know as the cacao bean. You can actually buy the beans that are roasted, or you can buy the fermented dried beans. So then once they're roasted and ground, it's at the grinding stage where it becomes kind of a paste and it's turned into these bricks, and then it's added with sugar, and that's what chocolate becomes, right? So chocolate in its natural form is not sweet. It's actually bitter, right? But it becomes the chocolate that you know and love once you add the sugar to it, right? Okay, so this is just to say you have a lot of different steps along the way to go from the basic cacao plant to the consumer product chocolate. And I'm not even going to talk much about cocoa butter and other derivatives. So anyways, you can make a number of measurements about this, like the rainfall, the labor rate, the cost of oil. And you might be wondering, what does the cost of oil have to do with the price of chocolate? Well, if you're going to package and transport it, certainly you're going to transport it in some vehicle, whether it's air freight or ship or ground transport. The cost of oil impacts the cost of gasoline. And if the cost of transport is more expensive because gas prices went up, of course, the product itself is going to be more expensive, right? And if you have a lot of transport steps in the supply chain, of course, it's going to be even more expensive. Okay, so that's why organizations like some restaurants will sign contracts with suppliers to say, okay, will you exclusively supply me with beef or with lettuce or with tomatoes? And they'll do that for multiple farms because they want to add redundancy to different steps in the supply chain to make it more stable in different geographic locations, so it's more robust to certain events that might impact the price. Okay, so there's a whole field called supply chain analysis. Right now, supply chain is global, right? Not just local to a single country. And if you're interested in supply chain analysis, there's a lot of employment and a lot of work in this field. And so, of course, one of the things people are interested in is analyzing the relationships between things. How tightly linked is the amount of rainfall to the consumer price of chocolate? How tightly linked is consumer taste, because tastes might change, right? People might like dark chocolate, and that might evolve into liking more milk chocolate, or people might like chocolate with nuts in it, or shift to chocolate without nuts in it. Consumer taste can change. What is the labor rate, the cost of labor? That's going to impact various things. But when you're analyzing these things, oftentimes you want to know the relationship, because if you know the relationship, how tight that relationship is, if one event happens, it'd be nice to be able to predict or at least understand what the consequence is for that event happening, right? So it's almost like risk analysis, but it's not for the purpose of assessing a cost with bad things happening. It's trying to understand, if I poke here, what happens over there, to understand the quote unquote physics of a system, right? So if you have a ball and you throw it at a window, right, a rock, and you throw it at a window, right, the window's going to crack or break. You know the consequence. Now, if your labor rate goes up, what is the consequence of that to various waypoints in the supply chain? So one of the things you want to ask is the relationship between these waypoints, both on the end product and steps along the way, and other things. Now, you've all watched these crime shows, right? And in these crime shows like CSI, what have you, they have this big board, right? And this board, they'll put in a pin and a picture of each of the major players involved in some event that occurred. And then over time, they'll collect evidence and piece together a relationship between various people, right? And then eventually, the slow music plays, it goes to black and white, and they're walking slowly. Is it going in to arrest the person, the music, all that stuff? But anyways, that's for dramatic effect. But evaluating relationships between people, right? So something happened and they learned that two people were college roommates, right? And they recently reconnected. That's an important point, right? So this evaluation of relationships, this kind of criminal sleuthing, is exactly the type of thing people do when they're trying to determine the linkages between factors along the way for the supply chain, right? And that gets harder and harder and harder the more steps you have going from raw material to finished product. Okay. Any questions about this? Does that make sense? Yeah. Okay. So there are many statistical tools you can use to sort of become a statistical detective. There are many tools that you can use to measure relatedness. And so one of them you already know. We talked about covariance, but more importantly, we talked about correlation, right? Correlation is the covariance over the product of the standard deviations. That's one such tool, but there are many other measures. One of the issues with correlation is that it only measures so-called linear relationships, and we'll discuss what I mean by that in subsequent modules during the semester. But nonetheless, it's one type that you already understand, and correlation encodes the unit step coupling between one measurement and another measurement. And it ranges between -1 and +1 on the real number line. A perfect correlation corresponds to a unit step increase or decrease in one measure corresponds to a similar unit step increase or decrease in another. And the positive or negative, the sign, represents the direction. Do I increase when the other measurement increases, or do I decrease when the other measurement increases? Okay, so there are many other relatedness measurements that you can make, both for tables of data as well as time series, things that vary over time. There's something called autocorrelation and cross-correlation for temporal sequences. And depending on how the semester goes, we might try some of those measures as well. And in fact, if you remember Constance's capstone project last semester using the Muse, which measures your brain waves, she was looking at cross correlation for the linkage between various electrode measurements. Okay, all right. So one of the questions, or some of the questions that you're going to answer when you measure these relatedness things, certainly, what will you measure, right? Because you might not need to measure for example, in the supply chain, all of the waypoints along the way. What types of relationships will you evaluate? So there are some relationships that say, do I, as a measurement, cause another measurement to do something? That's kind of like what correlation is measuring. Or do we march together in certain ways? That's a different type of measurement, and we'll talk about things like that. So what type of relationships will you evaluate? And then what statistical tools are appropriate? Some tools require a lot more data to be accurate or efficacious. Other tools work with a little bit of data. Some tools require temporal sequences, things that change in time. Some are just based on tables of data, right? And so context matters when you're talking about these relatedness measures. And we'll perhaps get a chance to kind of survey some of them. Okay. All right. Any questions about this? So, no? All right. So there's a lot of different types of statistics and a lot of different usages for statistics beyond just your plain vanilla take some data and come up with a number for the purpose of evaluation. We saw the sports example. We saw the Gini index that looks at the dispersion of wealth over a population within a country. And now we're looking at this risk assessment and this relatedness uses of statistics. Okay. Any questions? No? Make sense? All right. So one question you might ask, does smoking cause cancer? Now, of course, it's well known that smoking does cause cancer, but back in the 60s and 50s and 70s, it wasn't clear if smoking contributes to cancers, certain types of cancers. And so if you are going to test this assertion, and this deals with experimental design and talking about relatedness, you can't go out and run an experiment and say, okay, I'm going to find groups of people and I'm going to give this person so many cigarettes a day and that person so many cigarettes a day. That's against the law. You can't do that. So you can't do that. So what you can do is select a different type of measurement. You can say, okay, well, let me go out into the population and take existing cigarette smokers, and I'm going to recruit them into my survey, and I'm going to find people that have heavy usage, for some definition of heavy usage, some that have medium usage, and some that have light usage of cigarettes on a daily basis. So you can actually go out into the population and find them, right? That's a sampling problem, to kind of simulate this idea of what happens if you give somebody 1 pack a day versus 2 packs a day versus 2 cigarettes a day, and so forth. And so you decide what you can vary when you design an experiment when you're trying to determine some outcome. And in this case, because you can't physically manipulate the test subjects, it's against the law to do this, you can actually go out and find subjects based on their smoking habit and find different subjects that have different smoking habits, and that becomes your so-called control group. Now, this idea of a control group is very key to an experimental execution. A control group refers to that factor that you can vary. Because at the end of the day, you're asking the question, what is the impact of certain levels of smoking, right? So you can imagine kind of like a stereo control knob. If you turn it from 1 cigarette to 2 cigarettes to 3 cigarettes to 4 cigarettes, what happens on the other side in terms of incidence of cancer, right? And so you can absolutely do that. But the main point of trying to drive home with this example is that you have to identify the control group, because what the control group is doing is something that you vary, whether explicitly or by finding people for whom this particular measurement varies, but you have to find something to vary if you want to measure some effect. Right? So, for example, in the basketball sports example, where we talked about Michael Jordan versus LeBron James, perhaps we said, something, what if we, and I'm just making this up, the percentage of how many times the person passed the ball, right? When they crossed half court. And so you go through all the game film, or have people go through all the game film, and you look at the number of times each player crossed half court with the ball and whether they passed or they didn't pass. So then you look at different seasons or parts of the season and you say, okay, well, he passed it maybe 10% of the time, then 20% of the time, 30% of the time, 40% of the time. And then you look at the outcome of the game, right? So that control group in that case is the number of times that he passed. And you have these levels, and then you're looking at the outcome, whether it's a win or a loss. So that's another example of finding a control group. So um, in this semester, you're going to be asked to do a survey design, right? An experimental design, but it's really important you identify the control group, the thing you're varying. And as you vary that thing, what is the effect that you see as a result of varying that? Now, it's also called the control group because that should be the only thing you vary, right? So, for example, in this smoking example, you want to find people who are very similar in their lifestyle, and the only thing that they vary in is the smoking habit. Because let's say for these people, let's say if they varied in the amount of exercise that they get in addition to the number of cigarettes they smoked each day, well, that amount of exercise measurement is what becomes, it's called a confounding factor, right? Because you're now varying two things. And if increase in smoking caused cancer, someone could argue, well, it was really the lack of exercise that caused cancer because I noticed that for those who smoked a lot, they didn't exercise, they exercised less and less. So it really wasn't the increase in cigarettes, it was the decrease in exercise. Okay. So it's really important when you have this control group, especially in scenarios where you can't go out and instrument your population that you're studying. You want to make sure that this control factor that you're measuring, this measurement, is the only thing that you vary. So in the case of the smoking study, you would ask them all sorts of lifestyle things that would pertain to health status, like exercising, the diet that they have, as well as the number of cigarettes per day that he or she might be consuming, right? And then you say, okay, well, I'm going to reject these people because they all differ in the amount of exercise and diet. So you have people that have similar diet, similar exercise habits, but the only thing that differs is the smoking habit. So then you make a much stronger statement because the thing that you are varying in the group of people under study is just the smoking habit. Okay? Does that make sense? Any questions about this? Okay. So then you track them over time and you consider any factors that might influence what you're trying to measure and try as much as possible, as I said before, to keep them the same and only vary that factor of interest. All right. So what you do then, you have different tools of analyses, such as regression. And a regression analysis examines the linear relationship. There are other analyses that examine nonlinear relationships, but for now we're talking about linear because it's easy to explain at the outset without more tools. But you look at tools such as regression analysis. Now, regression analysis can be performed between two measurements. It can also be performed among multiple measurements called multiple regression. And this linear analysis or examination of linear relationships tries to tease out this idea of unit steps. So if an increase in the number of cigarettes, what is the increase in the likelihood for cancer, right? And then the other important part is, are your results significant? Right? So if you said, when you increase this consumption of cigarettes, there was a 100% increase in the incidences in cancer with just one more cigarette per day, well, is it significant? So if only one person had incidence of cancer and they increased the cigarette consumption and then now it went to two people, yes, absolutely, that's a 100% increase, but it's not meaningful, right? And so when you report or you find your results, you want to ask yourself, not only do I see my results and I know the relationship between multiple measurements, are these relationships meaningful? Are they significant? That's a really important thing to measure, right? And so, for example, if you go out and you read things like crime statistics, you go out and read things about poverty, you go out and you read things whose outcomes are very serious in that it results in the allocation of substantial resources or the non-allocation of substantial resources, it's really important to ask, are these meaningful results? Are they significant? Okay, because unfortunately, statistics, I think it's a wonderful thing, it is, but statistics can also be used willfully to deceive, right? It can, for a lot of very insidious things. So become very skeptical, right? And always ask yourself when you see a statistic, some outcome, well, how did they design the experiment? What was your control group? Are these results meaningful? Are they significant? And we'll talk about what these things are in more detail throughout the course of the semester. Okay? All right, any questions? All right, let me check the time. It's 10:13. We have about 30 minutes. Okay, great. So that's the end of the first module. Again, the project is due on the 21st at the usual 1 second before midnight. So I'm going to switch to the next module, and the next module is primarily on exit and show on visualization. So let me pop that up. Visualization. Okay. So as I said on Tuesday, one of the things you do when you have data is to look at it. And so we have some reading associated with visualization in the Barron book. It's not a lot of pages, about 10 pages in section 8.3. Please make sure you get through that in a week, so by next week, Thursday. Okay. So seeing is believing. And when you get data, you're going to spend about 60% of your time interacting with this data, understanding the data. And one of the first things you're going to do is look at your data. Now, if you're looking at the assignment, the IRS data set, you should look at it. And data sets, that's an easy data set. But most data sets are not always so straightforward, right? You're going to have lots and lots and lots of data. So, for example, one of our recent alums called me, and she was describing to me, she works at Accenture. She was describing to me a project that she's working on. It was her first project. This was over the summer. And it's to build a system for the U.S. Census Bureau. It's not sensitive material. It's so I can talk about it. She's going to build a system for the U.S. Census that's going to determine or predict whether or not an address is "quote unquote" vacant, right? And so one of the ground truth validations for that assessment is if the U.S. Post Office is delivering mail to that address. But she wants to look at other factors and for different communities for each zip code across an area to do that. And so, of course, this data doesn't just exist in multiple places, right? You have to look at all sorts of records from all sorts of organizations and put them together as one data set and then figure out a way to align it so you can identify all that information associated with each address in each zip code for an area. And so there are some areas where there are a lot of vacant properties, and there are other areas where there aren't that many vacant properties. But nonetheless, she wants to come up with a bunch of descriptions that will be good predictors of whether or not a particular address will be vacant and build a system to do that. And so that's typical of a real world problem. But the IRS data that we have for income is very, relatively straightforward. But nonetheless, seeing is believing. And for any sort of statistics problem, because statistics begins with data, you need to really examine, look at, excuse me, and think about your data. And the primary way you do that is by visualizing your data. Now, of course, sometimes it's good enough to just examine the raw data with the naked eye, right? Other times you're going to have to do some processing on that data to depict that data graphically, for example. And the reason why you visualize is because the visualization is going to help you decide upon what statistic or what functions are appropriate or most appropriate to transform your data in order to get that result so that you can draw the comparisons you want. Okay, so this is an interesting chart. This is a visualization of the pizza chains, and these aren't all the major pizza chains, but it's a couple of very popular ones of pizza chains throughout the United States. And so here we have a map of the United States, and this is a really nice way of showing geographic location. Now, it might seem obvious, but somebody had to decide, how are we going to display this? Now, certainly you had a database, and this database had a list of counties throughout the country. And in each line for a county, you had a list of all the major pizza chains from among those pizza chains represented in a table, right? So somebody had to decide to take all that data, and this is not the local mom and pop pizza chain. These are the national scope pizza chains. Somebody had to take that data and say, I have a great way to display this. Let's display this geo-registered on a map of the United States so that someone can just look at it and automatically kind of get a visceral understanding of what it's trying to get across. Now, of course, when you do it this way, it's a lot more apparent what's going on than if you just have it in a table. Because for a table, you'd have here's this county, here's that county, here's that county, and for each county record, you can have a list of all the pizza chains in that county, right? This is a lot easier to see what's going on. So who do we have here? We have Chuck E. Cheese, we have Cici's Pizza, which I'd never heard of until I looked up for the slide, Domino's, you have Godfather's Pizza, which I had never heard of until I looked up for this slide for the class. You have Little Caesars, Papa John's, Papa Murphy's, which I had never heard of until looking up for this slide, Pizza Hut, and Sbarro. Now, Sbarro is an interesting one. I'd never seen a Sbarro anywhere outside of a mall, right? Go figure. They're in other places. But anyways, so if you look at this, you can see, for example, there's a lot of green along the West Coast going from, say, Silicon Valley up through Oregon and Western Washington for green is Papa Murphy's, right? And so it's a quote unquote national chain. There's some green for Papa Murphy's sort of in the north, like Chicago area, Indiana area. But there's mostly concentrated on the West Coast, right? And so there's something about Papa Murphy's. Maybe that's where they started on the West Coast, and so they kind of expanded out. But you don't see much along the lines of Papa Murphy's, that dark green, along the Mid-Atlantic area or the eastern half, of the country, especially the Atlantic coast. Okay, so if you look at Cici's pizza, that light blue, right? You see some Cici's pizza kind of dotted, looks like Texas, kind of going up to like the Dakotas and towards Chicago and the Illinois area, but you don't see Papa Murphy's really much anywhere else. Now, if you look at Sbarro, well, Sbarro, that kind of looks like purple. You see Sbarro's mostly on the Northeast corridor, kind of tracking where Amtrak goes from Boston down to DC. But you don't see Sbarro. I mean, there's a Sbarro here. We don't see Sbarro anywhere along the lines of, dotted throughout the country, many other places. And then Pizza Hut, I was kind of surprised at how pervasive Pizza Hut is. Because Pizza Hut, at least in this area, isn't huge, but they're all over the place. It looks like they dominate the eastern half of the country. There's a lot of Pizza Hut all over the place. And then if you look at Little Caesars, they seem to really like Little Caesars here. That looks like, where is that? That's geography. It's Michigan. Thank you. It's Michigan because those are the Great Lakes, kind of like two fingers grabbing Michigan. So Michigan. Thank you. So they really like their Little Caesars. That's the orange in Michigan, right? That's dominating Michigan, which was interesting. So Papa John's, it looks like you have a more Papa John's, kind of like the Tennessee area, and then of course you see, where is it? Godfather's. There's a little bit of Godfather's in New York and whatever that is. And you have some Godfathers sprinkled out. So that's just to say, here you have these pizza chains, and it's very easy to see the saturation of pizza chains throughout the United States. Now, what was surprising to me, if you look at four corners like Utah, Arizona, New Mexico, you don't have that much pizza to begin with. Now, it's not very dense there. Now, you might think, oh my gosh, those poor people in those states, they don't eat pizza. Again, these are the major national chains, right? So there could be one of two things happening. Either they don't have a lot of pizza because these chains do a lot of market research about tastes, and maybe they decide not to locate in certain regions because it's not profitable, or it could be that the local taste is such that they prefer the local mom and pop pizza shops over the large national chains. So this aggregate data does two things, right? It's geo-registered, and in doing that geo-registration, it also uses color to catch your eye and draw your attention to this idea of both market dominance as well as regional preference, right? Because some pizza chains are more preferred than others. It was really surprising to see how much Domino's is preferred along the Atlantic coast. Something about coastal, they like Domino's, go figure, right? And so there are other charts like this that are geo-registered, and let's say you were a builder and you wanted to know where you were going to build new housing, right? You might use pizza chains to kind of tell you something about where people live in certain demographics. Or if you were a shopping concern, or let's say you wanted to send advertisements for certain products, where are you going to send it? Well, you can use something about this graph to help you decide population density, for example. Because Domino's, they like to deliver, and people who like delivery tend to be maybe they're pretty busy, they're balancing a career with home life, and perhaps if you are doing a home delivery of groceries, that might work in areas where you see a lot of Domino's, for example, right? So let's look at this other graph. This is a population density graph, and for this graph, it's a kind of relief map, and for certain locales, they take the population and they kind of draw a little peak, if you will. The height of the peak corresponds to the amount of the population, right? And so the largest municipality here is New York City, and you see there's a really tall spike here representing the relatively much larger population of New York City. And after New York is Los Angeles, and that dot for some reason is down here when it should be at the top of that peak. And then after that, you see Chicago is pretty high. And then Philadelphia is right here. Philadelphia is the fourth largest city in the United States by population. Okay, so if you take that chart, and it's interesting, if you could kind of tilt this chart and stretch it out to match the size of the previous chart, the pizza chart, you're going to see an interesting coincidence here. So here, along the Northeast corridor from Boston to DC, right, there's a really big population density. And that goes back to, human civilization. People originally liked to live along the coast because water is essential to life, right? You can get food from water in the form of fish. Also, water, once you purify it, you can drink it. Life needs water to exist. And so here along the Northeast corridor, the Atlantic coast, you see a huge amount of population, right, in a very small, relatively small space. And so if you go back, you'll notice Domino's sort of mirrors this population density across the Atlantic coast, the Northeast corridor, which is the most frequent route served by Amtrak, consequently, from Boston to DC. And so if you look in the Midwest here, in Michigan here, you have some spikes there. And if you go back, you have a lot of Little Caesars. I don't really have a good explanation for that, but it's there. And you can really see here, there's population, 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 and then you have some holes here where there's not very much population, primarily in four corners. There's Utah, there's Nevada, there's Arizona, right? And if you flip back, that's exactly where the holes are in terms of the national pizza chains, right? And so the pizza chains tend to like to serve areas that have relatively higher population density. And if you flip back and forth between the population chart and the pizza chart, yeah, the holes are roughly in the same place. And so what this says is that these national chains tend to prefer to locate where there's more dense population. Okay, all right. Any questions about this? Does that make sense? And so what this says is that you can take all sorts of statistics or all sorts of data, and if you visualize them appropriately, you can discern all types of information. Now, of course, if you are a builder or if you're an advertiser or what have you, right? Oftentimes, you have a budget, it's a fixed budget. you can use other information from the Bureau of Labor and Statistics, from the U.S. Census, and all sorts of organizations, as well as from, this is probably called by the Pizza Association. There are all sorts of professional organizations. But you can use all sorts of information from other domains to help you in a new domain. Right? And so this idea of appropriately visualizing your data is really, really important to determine statistics that you're going to use to make a statement. So if you were Delaware State University and administration, and you decided you want to increase the student population and you want to do some recruiting, of course, where are you going to recruit? Where there are more eligible college students in the pipeline. And so you might choose to say, okay, well, let's disperse some recruiters to various high schools and other places throughout this area, maybe throughout this area. And because perhaps you want some geographical diversity, you're going to dispatch some in this area. Now, I know DSU doesn't go to the West Coast when they do recruiting, but maybe they should. So that just says you can use this information to determine in an intelligible way how you're going to commit resources and therefore get efficient usage of your dollars that you're spending to do something. Okay? Now, of course, there are people whose jobs are to create visualizations, to come up with clever and interesting visualizations. And you can actually get a graduate degree just in visualization and graphics, right? Where you're looking at all sorts of statistics, all sorts of charts, and all sorts of things like that. Okay? Folks who are quote unquote analysts, especially for the financial industry, they're very, very highly sought after because if you can create the quote unquote right visualization, you can highlight data that can be very strategically important for a company, some enterprise, or some financial institution. Okay? All right, any questions about this? Does that make sense? All right, so let's continue on. So you have some data, and the first thing you do is you look at it, right? And there are different ways of looking at that data. Now, more than before, it should be obvious you look at the data. Well, let's take a look at the different types of data we can have. Because data isn't just data, data is highly categorized, and knowing what type of data you have will help inform you of the types of analyses that you can perform on that data. So the world is full of objects. There are things that are not dividable, things like a cat, a dog, or a truck. And some objects you can't really divide and you can't really measure. And when I say measure, I don't mean you weigh the cat or you describe the color of the cat. You can't like pull a cat apart and say this cat compared to that cat, right? Or truck and so forth. Now, these particular objects have these labels or categories as they're called, and for that reason they're called categorical variables. So a categorical variable is some variable whose measurement has a particular label. Now, it also happens that a categorical variable, well, you can't really naturally order it, right? Now, certainly you could sort them alphabetically. C comes before D, D comes before T, but there's no natural way to say, if I have a picture of a cat and a picture of a dog, how do I sort them in some order, increasing or decreasing, for example? You just have to find a way to put them together. So these categorical variables refer to measurements of objects, and therefore they're assigned categories, things like a dog, things like a cat, or perhaps a truck. Okay, so some categories have no natural ordering. And when there's no natural ordering, it's called a nominal categorical variable, right? And this is to give you some vocabulary so that when you start reading the literature and dealing with more real data sets, that you understand what they're talking about, because we will cover some other data sets in subsequent assignments. And so these nominal categorical variables have no natural ordering. If you have this cat and this dog, you can't really put one in front of the other in a sorted order. Now, certainly, if you assign it a label, you can say, I'm going to do it alphabetically, but why should cat come before dog, right? Why not dog before cat? You could put the dog before cat, right? So there's no natural ordering, means they are nominal. But there are some categories, so-called ordinal categories. Now, the rating scale for movies, bless you, is ordinal categorical variables. So you have these different ratings. There's general, there's PG, there's PG-13, there's R, there's NC-17, right? Now, these ratings talk about the maturity associated with the content of the movie, right? From very immature, and when I say immature, I don't mean bad. I mean immature as in, not ready for the salacious stuff, um, to very mature on the NC-17. So while they are categories, because these categories have meaning, you can actually put them in some natural sorted order. So G comes before PG, comes before PG-13, comes before R, comes before NC-17. Okay? So this is an example of an ordinal categorical variable. Okay, does that make sense? Questions? No? All right. So we also have quantitative variables. These are not categorical. These describe measurements or data items that can take on a numeric variable. Now, because they can take on a numeric value, they can absolutely assume a sorted natural order, right? So if you have one, have two, have three, you can sort them in numerical order, one, two, three, right? For example. Now, in this example, well, you can look at, for example, a house, the front elevation of a house, right? How high up the front of the house is. All right, that's a measurement in distance, and you can actually sort them based on those distances. Likewise, for storage tanks. Storage tanks are categorized in terms of, or described in terms of the amount of gallons of liquid that they hold. So you can absolutely sort them based on this size when you describe them. I would like to buy a 50-gallon tank or a 100-gallon tank. Which one is bigger? Which one will fit? Well, the bigger one's not going to fit in the same space as a smaller one. And so this is a so-called quantitative variable. It's a number, and it can be ordered in a natural way. Okay. So we have two types of quantitative variables. We have continuous, which this should be very old hat from last semester, which is uncountably infinite, it's real valued. And we have discrete, which is countable. So countable could be an integer, right? 1 gallon, 2 gallons, 10 gallons. Okay. So we also have nuances of these things. So for every rule, there's a nuanced exception. And let me describe a couple of them. So sometimes these types blur, right? And so if you're dealing with something like gender, right? Well, those are categorical variables, okay? Sometimes years, well, years are numbers, so you can treat them like they're quantitative, discrete quantitative variables, but other times years are categories, right? You can treat a year like a categorical variable. So let's say, you're talking about graduating classes at DSU, right? You can list the number of students that graduate in each graduating class. So you say the class of 2010, the class of 2011, the class of 2012, and you have a graph where the horizontal axis is the year of graduation and the vertical axis is the number of people that graduated. In that case, the year looks like an ordinal variable. Not ordinal, a quantitative discrete variable, right? You're using it as a number and you're putting it in its natural order. Suppose you were looking at something like the amount of student loans people for each graduating class have, right? So the years look like categories, right? Not like ordinal things, because here it doesn't matter which one comes first. It's used as a category to describe a group of people, not some number that has transpired and increased, looking for trends over time. Okay, does that make sense? So absolutely there are nuances. So please make sure you pay attention when you're looking at data, whether they're treating numbers as numbers or they're treating numeric variables as if they were categories. Okay, all right. So let me check the time. 36, we have 9 minutes. So let's take a look at some visualization. And this should be very straightforward for all of you. There are different charts you can use to depict your data in order to get a first level view of what this data contains. And so there's the bar chart, and the bar chart has your categories along the horizontal axis. So here, these are seasons of the year, and then it has a numerical count along the vertical axis. Now, you can do this with a typical spreadsheet quite easily, but MATLAB also has APIs to do this as well. So in this particular case, you're looking at the number for a single family, the number of children born in a particular season of the year. And so right away, you can tell because summer and fall bars are much higher, that more children in this family were born in summer and fall versus the spring and the winter. Okay. Now, because these are categories, it doesn't matter what the order is if they've chosen to list them in spring, summer, fall, winter. But you could have easily, for example, when you're talking about the academic calendar, we talk about fall and spring, right? So we list, the first semester and the second semester because of the rhythm of the school year. And so the bar chart is equally valid if you reverse the order of these categorical variables. It still carries the same information. Okay? So this is a bar chart, and it's important, of course, to have a legend, which is this box on the right here, to describe or summarize this data. Okay? All right. Any questions about this? Pretty straightforward. All right. So a bar chart can also be used to illustrate the relative relationships between these different categories, right? So in this particular graph, on the horizontal axis, and you'll notice that when I describe it, I'll tell you what the axes mean, right? And that's really, really important whenever you're presenting visualizations to people, because it gives your audience the ability to understand and see for themselves what the chart means, right? So this chart talks about the differences in terms of the level of employment for different companies, who has more employees. And so along the horizontal axis, we have a bunch of shopping concerns. Walmart, Yum Brands, which owns like KFC, Taco Bell, they own a whole bunch of stuff. McDonald's, IBM, UPS, Kroger, which is a supermarket, Target, Home Depot, and HP. Now, along the horizontal axis are the companies, and along the vertical axis, we have the number of employees as a count. And so certainly if a company has more employees, its bar is going to be higher because the count is higher. So here, higher means more employees, right? And that's another important aspect. Not only do you describe to your audience what the axes mean on your bar chart, you also give your audience a sense of how to interpret the chart. Right? So I describe the horizontal and vertical axis, and I just told you that the vertical axis represents a count and the horizontal represents the company, and then higher means more employees. So right away, the audience knows that, okay, there's something about this one, it's higher, they have more people that are working, right? You should help your audience to be able to interpret any sort of visualization. Okay, so in this particular graph, we see Walmart is the outlier. Walmart has a lot more employees than all of the others, right? And that makes sense because they have a lot of stores throughout the country. Okay, any questions about this? And so you can use bar charts, like for this example, it started out as just a data table, and perhaps that data table listed the individual Walmart stores, and for each store, how many employees worked there, and likewise for all the others. But when you visualize it as a bar chart, it becomes immediately apparent what the differences are between Walmart and all the other shopping concerns. Right, so you could say Walmart has more than twice, looks like 3 times as many as employees as number 2, which is Yum Brands. Okay, all right. Any questions about this? All right. So you can also use a bar chart to depict what's called the relative frequency. Now you're dealing with probabilities, right? So you take your frequency chart from before, and then you divide each category by the total number of counts. Right? So this is the same Jones family chart, but now they've taken each bucket, if you will, each category spring, which had 1, and you divide it by the total number, 5, and you come up with a proportion. So now you're dealing with percentages or probabilities, if you will. So now you can say, for the Jones family, a full 80% of the children were born in summer and fall, right? So you have 40% in the summer, 40% in the fall. So you can absolutely take these charts and you can transform them through some calculation. In this particular case, you divide the counts for each category, the height of each bar, you divide it by the total number of counts for all the measurements that you have. And right away, you can now traffic in percentages instead of just raw counts, right? And for some problems, it's important to talk about percentages. So let's say, if you were an administrator at DSU and You talked about, maybe for in-state versus out-of-state students, the percentage that graduated in 4 years versus 4.5 years, for example, right? So now you can talk about percentages, or maybe for spring for spring semester and fall semester and spring semester of the 2019-2020 academic season versus the 2018-2019. You can talk about, was there an increase in the number of students who did something, right? Something interesting. And when you traffic in percentages by transforming your bar charts, you can actually get a better picture of what's happening in your system you're studying and the statement that you're trying to make. Okay? So sometimes you want to traffic in counts for the bar charts, sometimes you want to traffic in percentages, and it's an easy transformation to make. Any questions? Okay, so what time is it? 10:43. Let's end there, and we'll pick back up on Tuesday with the balance of this and keep going forward. Please make sure that you're looking at the assignment. And MLK Day is on the 20th. So I will see you on Tuesday.